is connected when it comes to factoring, okay? So it may seem at some points like we're doing different things every day. I will let you see later on that it all comes together and it's all really connected, right? So today, I'm going to introduce you to factoring where a does not equal to 1. No matter what you do, it's not going to work for us, okay? So polynomials of the form ax squared plus bx plus c. So when you're factoring like in binomials like that, you're looking for something that looks like that, right? Except for today, we're going to look at a is not equal to 1. Even after taking out, I will put this in brackets, okay, because this is just me, even after taking out the GCF, a common factor, okay? There's nothing that you'll be able to do. It'll just be a trinomial where a is not equal to 1. So I will tell you steps that we've been taking so far. Steps to factor fully, okay? And I suggest you do that in this order. So first you will look at, do I need to rewrite? And this is only if necessary, okay? If the y squared over the x squared is at the end and you want to bring it to the front, right? So you're looking for these things. You're not necessarily going to have to do all of these things, okay? Take out a negative, right? Or GCF. And what I mean by GCF is common factor, right? You're looking, are there numbers that they all share that I can take out? Are there variables, right, that I can take out? Okay, so negative for sure, and then see if anything else is there. And then third, if trinomial has a equal to 1, right? Use the multiply sum method. Like that's what we've been doing yesterday and today in today's AC. The multiply sum, right? Find two numbers that multiply and add up to b, right? Maybe I'll just put that multiplied to c sum to b. Okay, that's the method that we're going to be using. That's what we've been doing yesterday and in today's AC. But now I'm going to introduce you a new one. So that'll be the fourth step. Like if this isn't happening, then we're entering the fourth step, which is if trinomial has a not equal to 1, use matrix method. Matrix method? I've never heard of that. I'm glad you asked, right? We're going to do that today. Matrix method. We're going to do some examples. Okay, I'm going to slow down here because some of you are still writing down. Try to catch up. oh, I'm gonna pause the. Let's keep going. Matrix method. Let's do some examples and I'll give you some notes as we go, okay, on that. So let's say you have 2x squared plus 7x plus 6, right? And you're thinking, right? I'm not going to close that cloud yet. There is no GCF to take out. Right? And we notice that A does not equal to 1. A is not 1, right? So you're trying 2. Can I take out a 2? No, 7 kind of ruins that for us. Can I take out a negative? No, because the x squared doesn't have a negative. I don't need to rewrite. There's no common variable, so I'm kind of stuck, right? So now this is the scenario where it's like, okay, I got to use the matrix method here. Okay, so what you do is you kind of make a little matrix here, so like a little 2x2 box. So I'm gonna make I'm gonna make several ones until we get to the right answer, just to show you what this could look like. Okay, so what you do is you take the factors of A. What makes A? In this case, it's only 1 times 2, and it's most likely going to be very predictable. 1 times 2, 1 times 3, 1 times 5, right? It's going to be a prime, like it's going to be most likely a prime. And so we go 1 times 2, like this. So these ones here are factors of A. Okay? You put the factors of A first. And then here, you put in the factors of C. Okay? You put the factors of C here. So an option would be 1 times 6, right? Like 6, the factors of 6 is 1 times 6. Right? So you put it down like that. And I'm going to give you the notes on the signs right now. Okay? Let's use this space on the side here. If C is positive, they will have same sign as B. You'll have to add. It's just to help you out, right? If C is negative, you're going to have opposite signs. And you will have to subtract. This is an aside that will help us coming up with the two numbers there. Make sure you write that down and then I'll explain that. I don't know if you want to memorize it, CSA, right? COS, but I don't know, it would probably be hard to use that, but this will, after a while, this will just become a second nature. You'll just know what to do, okay? So let's use this for this question to make it a little bit easier to find out what we need to do. So C is positive, right? We notice that. That means that both of these factors of C will have the same sign as B. That's what I'm trying to say here. and b is positive as well. So we can be guaranteed that both of these will have to be positive. And add, that's what comes next. So what you do in a matrix method is you multiply across like this and like this. You make an x. So it's 1 times 6 is 6, positive. That looks like a b. That's a 6. And 2 times 1 is 2, positive. Right? And then you check, do these two add up? What do they add up to? That's what I mean with adding. You're going to have to add. Even if they're both negative, you add them, right? That'd be positive 8. Positive 8 is not the same as b, so this does not work. Right? Does not work. This setup right here, 1 and 6, we get positive 8 out of that. It does not work for us because it's the same as before. Like we want the product to be, or the sum to be same as b, right? So we'll try another one here. And here's the secret, okay? Do not flip 1 and 2. That stays the same. Like once you've determined the two factors of a, you keep it like that. What you're trying next is to change these here. Okay? So let's try to, sometimes it helps to just flip these. So you go 6 and 1. Because 1 and 6 doesn't work, we're going to flip the 1 and 6 to 6 and 1 and try it again. This gives us positive 1. This gives us positive 12. And you know already that that isn't going to work either, right? We need 7. There's an 8 when you do it this way, 1, 6. If you flip these two and try it again, you get 13, not working. So we're going to try another one. And I'm going to try 2 and 3. Okay, because 2 and 3 are factors of 6. You're going to go 1 times 3 is positive 3. 2 times 2 is positive 4. That adds up to positive 7. And this is B, right? So we check that off. This is what we're going to use. This is the matrix we're going to use to factor our polynomial that we started off with. Okay, now watch carefully. This is a pair and this is a pair. So what you do is you go 1x plus 2, right? 1x plus 2 goes in the first bracket, and the second bracket is 2x plus 3. So you have to have a variable, right? What is the variable in this case? It's x. So it's 1x plus 2, because we kind of take this pair and we plug it in here. And then we take this pair and we plug it in there. Close brackets. Okay. And I kind of, this is going to be a bit of an issue, but you want to do the double smiley face check. Let's just do it like this. This is 4x. And this out here is positive 3x. Right? 4x multiplying these two, and 3x, that gives you 7x. So that checks out. Okay. I would like you to not write the 1 in front. Right? You can write it like this, x plus 2, 2x plus 3. Okay, and let's do a quick check. 4x, 3x, they're all positive. That is 7x. Checks out. And if you were to multiply this out, you should get back to the original trinomial. Okay. Now, you might ask, whoa, like I have to do all of this every time? Not really. Like I'll show you that after a while. If 1 and 6 doesn't work, I just erase this. and I try flipping it, if that doesn't work, then like you will do a lot of this in your head, right? You will try out and then very quickly realize that 2 and 3 work. One more word of caution here. If you had flipped this, if you had put the 3 up here and the 2 down here, right, on the one that worked for us, it's not going to work. Like it's going to be a completely different answer. It will be 2 times 3, which is 6. 1 times 2 is 2, that would be 8, right? That it right away would change this. So it is very important to keep the order in the right place. Okay, let's try some more. Okay, B, we have negative 3n squared minus 8n minus 4. Minus 3n squared, or negative, right? Minus 8n minus 4. Okay. I have a little sticky note here to help us remember the rules, right? Do I need to rewrite? I check. No, it's already in the right order the way I want it, right? Take out a negative or common factor, right? The GCF. Oh, I have a negative, so that one for sure is gonna come out. Is there anything else they share in common? I can take out a 3 because that's your first go-to. Try to take out that 3, but you can't, right? It doesn't work. In fact, nothing else works. So we're gonna take out the negative, and then we're gonna see which one of these two we end up with. So that is negative, right? 3n squared plus 8n plus 4. Okay. And then you're stuck between camp 3 and camp 4, right? Does a equal to 1? I look. Nope, it does not. So I can't just use this simple multiply sum method. I can't use the one I've been using so far. I have to use the matrix method because a is not equal to 1. Okay, so now my sticky note will go away. So what you do is come over here on the side, somewhere on the side. The factors of 3 is 1 and 3. And the factors of 4 is what? 1 and 4, right? 1 and 4 would work. So let's try 1 and 4. And keep in mind, C is positive. That means I'm going to have the same sign. Factors are going to have the same sign as B, right? Which is also positive. So I'm going to have to add my products here. So 1 times 4 is positive 4, right? 1 times 3 is positive 3. That adds up to 7 positive. That does not work because B is 8. So it doesn't work. Let's try another one. 1 and 3. I'm just going to try flipping it. 4 and 1. Right? 1 times 1 is 1. 3 times 4 is 12. That gives me 13 positive. Not going to work, right? It's still not going to work because I get a 13, I want an 8. So let's try again. Notice that I'm not flipping the factors of A. I'm just trying something with the factors of C. I'm going to try 2 and 2. And I multiply like this and like this, right? I get 1 times 2 is 2, 3 times 2 is 6, and that gives me positive 8. This is working out for me. So this is the matrix I'm going to use. Okay, that's the matrix I'm going to use. So now I'm going to come back here to where I was doing my work. I'm not going to forget about the negative, okay? Promise to yourselves, like, I promise to never forget about the negative, right? Just do something like that so you don't forget about it, because that happens a lot, okay? All right, so then it's x and 2, so it's x plus 2, right? 1x plus 2, that I got from this here, okay? And then it's 3x plus 2 on the second bracket. Oh, Mr. Dirksen, isn't it n? I'm glad you mentioned that, right? It's n, not x, okay? I'm glad you brought that up. I'm talking to myself here, okay? So that is what the fully factored would be. Take out the negative, take out the GCF. I'm left with a trinomial. Oh, it's a equal to 1. That's the easy one. A does not equal to 1, matrix method. That's this method we're doing right now, okay? So I'm going to leave it up there a bit, and then now we're going to try to switch it up a little bit. Like we're going to have a negative here for C. See how that changes. C 7x squared plus 18x minus 9. Do I need to rewrite? No, right? It's already in the right order. Do I need to take out a negative? No. A is already positive, so don't bother. Can I take out a common factor, a GCF, right? GCF. Can I take out a GCF? 7 doesn't go into anything. In fact, there's nothing I can take out. No number, no variable. So is the trinomial that I got after applying the first two steps, is it equal to 1? Nope. So now I'm stuck with trinomial where a is not equal to 1. I have to use the matrix method, okay? So I'm going to start, I'm going to have this here next, but I'm going to start my matrix method on the side here. So 1 and 7. And before I start, this gets a little trickier, right? C is negative. All right, I'm going to put that here. C is negative. That means that my factors are going to have opposite signs. And you will end up having to subtract, and you'll see what I mean in a bit. Okay. So let's try, you might want to try 3 and 3 right off the bat. Okay. So if you try 3 and 3, one of them has to be negative and one positive because they have to have opposite signs. So if you make this negative, right, 1 times negative 3 is negative 3. 3 times 7 is 21. Positive, right? If you add these up, or actually you will subtract, right? 21 minus 3, what do you get? You get positive 18, which is exactly what you want. Okay, so sometimes it's just going to work out right away. Let's put one here that does not work, okay, because most likely you're going to try things and they're not going to work right away. And I don't want you to panic, okay? You just stick with it, right? 1, 7. And let's say we had put the top, like had put the negative up top, right? And the other one, you would get 7 times negative 3 is negative 21. 1 times 3 is positive 3. In this case, you would still subtract, but you would get negative 18. This does not work, okay? This will not work. This works because B is 18, right? So let's come up with our, so this matrix is the one I'm using. So it's x plus 3, 1x, right? 1x plus 3. And on the other one, you'll have 7x minus 3, like that. And you have fully factored this. Even though it doesn't look like you've done a whole lot, this is fully factored, right? So 3 times 7 is 21x. X times negative 3 is negative 3x. That's 18x. Check, right? Because if that doesn't add up, go back to the drawing board. You have to start over. Okay, something is wrong. So, Mr. Dixon, but could I have tried 1 times negative 9 and then negative 1 times 9, right? Like tried that? Yeah, you could have, right? And it would have taken probably a little longer to get there. Okay. Here, let's try another one. D 6n squared minus 7n plus 2. Give that a try. E 3 minus 2m minus 8m squared. So give those, at least D, give that a one a try, see how you do there. Okay, I'm going to try D here. Again, I go through my checklist, right? Do I need to rewrite? No. Do I need to take out a negative? No. Can I take out a number or another variable? Nope. Okay, so A is not equal to 1, so we have to try the matrix. So I'm going to go 2, 3. Okay, 2, 3 or 1, 6. It's really, that's where you have to, you might want to try 2, 3 or 1, 6, right? So 2, 3, and for 2, the factors would be 1 and 2, right? That's pretty obvious. Now you look at the sign, right? C is positive, right? So they'll have the same sign as B, right? And you'll have to add at the end. So B is negative, so we know that both of them are going to have to be negative or else it doesn't work. So 2 times negative 2 is negative 4, right? 3 times negative 1 is negative 3. That adds up to negative 7. That's exactly what I want. But let's say you tried 1 and 6, right? 1 and 6, and you had a pretty good feeling as negative 1, negative 2. Okay? Then it would have been negative 2 and negative 6, which add up to negative 8. And this does not work, right? Negative 8 wouldn't work. So then you try, you're starting to be like, okay, let's see. I'm going to go negative 2, negative 1. I'm going to flip this like that. I'm going to flip the second because that's the only one I asked you to flip, right? Then you get negative 12 and negative 1, right? And that would have given you negative 13, which also doesn't work. And when you roll, like especially the 2, right, there aren't that many options for 2, right? It's 1, 2. So if 1, 6 doesn't seem to do the trick, right, then you're going to have to resort to trying different factors for the first one. It doesn't happen very often. Most of the time, the first one, you don't have to play around with it, but this is the only one that works, okay? Basically, what I'm going to put in our notes is if it doesn't work, change factors of A, okay? That's basically what I'm going to say here. If it doesn't work, change the factors of A. So every once in a while, you're going to have a case like that. But I would first try with 1 times the number and exhaust my options here with switching the second one, and then move over to, let's try 2 times 3. And then you basically run through the factors of E, right? So now if this works, right, that means that this will result in 2n minus 1 and 3n minus 2, right? So 2n minus 1, 3n minus 2. And then I will just say, I will have an arrow from here going to there, okay? And maybe it's probably a good idea to highlight, right, that you tried 1 and 6, 1 and 6, and then we switched over to 2 and 3. And the key to remember is there's only one way to factor. There's not more than one. Okay, there's only one way that it's going to work out for you. Okay. Next, I need to rewrite this. So negative 8m squared minus 2m plus 3. So rewrite. I will make a note here. Rewrite, take out negative. Okay, that's my plan here. And so I'm going to go negative, and that's 8m squared plus 2m minus 3. So this negative changes the signs of all the terms inside the bracket. And then you try your matrix. Okay, so you can try 1 and 8. And notice this. C is negative. I don't want to write this down every time, but C is negative. So you know that they're going to have opposite signs here. So let's try 1 and -3. So this is 8 positive, and this is -3. That adds up to 5. Or when you subtract it, it's 5. It doesn't work. You need a 2, right? Let's keep trying. 1 and 8. I'm going to go -3 on top and 1 at the bottom. Try that out. And you get -24 and +1. That for sure, like you don't even need to add it up, right? It would give you -23, right? If you do that. So what I did is I actually just flipped this. I flipped the actual number. What you could have also done is just to put the negative on top. So I will do that. 1, 8. And just leave it like this, 1 and 3, but I will make the 1 negative and the 3 positive, right? And then you get -8 and +3. That gives you -5. It doesn't work, right? So these all are not working out for me. So now you need to resort to changing the first, okay? So I'm going to try 2 and 4. This all didn't work, so I'm going to try 2 and 4. I'm going to try 1 and -3. Okay? Multiplying across, you get -6, and you get +4 here. Will that work out for me? You get -2. That still doesn't work. So then you keep going. 2, 4. I'm just going to put the negative up here. -1, 3. That's 6 positive, and that's -4 up here. If you add that up, you get +2. This works. Okay, so this is the winner. So you use this. Don't forget the negative. You go 2m minus 1, and then you go 4m plus 3. And that's your factored. And if we do a quick check, this is -4m, and this is +6m. That adds up to +2m, which is what we want. I know it's heavy, but why I'm making so many, giving you so many examples of it not working is because if in my notes I just give you the one that always works, you are gonna feel like, oh my goodness, there's something wrong with me, right? So I'm showing you, it's like, no, it could take a while until you find the matrix that works. Okay, let's do this one here. Do I need to rewrite? Nope. I can definitely take out the negative, and they're all even, so I can definitely take out a 2. Okay, that leaves me here with 6 positive m squared minus m minus 5. Start my matrix. And I'm going to go with 2 and 3. You know, I'm going to try 2 and 3 here for this one. 2, 3. And remember, if C is negative, they're going to have opposite signs here. So I'm going to try 1, -5. See if that works. And this is going to be faster after a while, right? So that gives you -10. And that gives you +3. You get a -7 out of that. Doesn't work. Try 2, 3 again. I'm just going to put the negative up top, put the 5 down here. That gives me a negative 3 and a positive 10. That gives me a positive 7. And you could have predicted that already. If you change the sign, you will just get the same answer with different signs. Okay, so you could have kind of eliminated this one already just by looking at that you get a 7. That's not going to work for you. So we've exhausted the 2, 3. Another thing that I'm going to try is 2, 3. Bring the negative 5 up here and the 1 down there. I'm going to try that. Some of you are seeing already, no, Mr. Dirksen, it's not going to work. I see it, right? So that's that. That would be negative 13. Okay, that's not going to work. So don't try to just flip the sign here. I need to resort to 1 and 6. Right, 1 and 6. And I'm going to go try 1 and negative 5 like this. Okay, that gives me positive 6. That gives me negative 5. Oh, this is almost working because you get positive 1. I need a negative 1, right? So you just know that you're going to have to flip the sign here. 1, 6, negative 1, 5. Because if you do that, you get negative 6 here, and you get positive 5 there, which is negative 1, which is equal to B, and that's exactly what I need. Sorry, you can't see that, right? So here's another piece of advice I'm going to give you, okay? If you tried 2 and 3, right? And you tried 1 and 5, of course, one of them has to be negative. When you see that you get a difference of 7, abandon this method. Like, don't even flip the sign because you're just going to get the same answer with a different sign. Then you try flipping the numbers. You get 13. That's not going to work for you. Abandon this particular setup. You change that, you go 1, 6 and negative 1, 5, and you get that. Okay? So we're going to leave it at that. I'm going to give you the homework here. And that is 3.6, right? We're going to go page 177. We're going to go question 13, B, D, F, H for now. We're going to try 15, 18, and 19. Let me just give it a quick look here before you pack. So 13, yeah, 15, 18, and 19. Yes. Okay. That is it for today. Okay.